Welcome to a special session of JEE at Helm of Science. Today we will discuss about some important questions, some simple questions on JEE physics. So please keep watching this video till end. Thank you. The main aim of this making this video is students always commit some simple mistakes of some simple questions. So we will discuss some basic questions which have already appeared in the previous JEE examination, various JEE examination. So how to keep safe from those kinds of mistakes, please watch this video. So in our first question it is given that the mass of the body is 6 kg, right, and it is displaced by an amount that displacement is x, displaced by amount t square by 4, t in second. So what is the displacement, what is the work done in 2 seconds? This is our question. So when we need to calculate the work done. Work done is force into displacement. So we need to calculate force, and force is written as F is equal to m dot a. So the m is the constant and a is the variable. So we have to calculate a and put it here, and we can easily find the force. So x is t square by 4, and we know velocity is the derivative with respect to time of the displacement, and it is ddt of t square by 4, and it will become t by 2. And again acceleration is dvdt, that is the double derivative of displacement with respect to time, and it will become half. And if we ddt of t by 2, and this is half. So work done is equals f dot ma, f dot ds, and f is equal to ma dot ds means the displacement. So let's get the board here. Number one question it was. So we are going into this. So m is 6 and a acceleration we found half, and there is s, that was t square by 4, and t square means at t is equal to 2, so 2 square by 4, so it will be 3 cross 4 by 4, that is 3 joule. So number D will be the correct answer. In the question number 2, if we draw the free body diagram, here was a spring and a mass was traveling towards the spring, and after this it compresses the spring like this. So the spring was here and now the spring is here, so we need to calculate this displacement. So some constants are given, that is mass is 2 kg and the spring constant is 1000 Newton per meter. So we know applied mechanical energy is equal to that work done against the friction force plus the potential energy, elastic potential energy, whatever. That is, the mass is traveling on this way, so it is experiencing a friction force with the ground, and the potential energy of the spring will resist that block from moving towards. So the total applied energy by this block on this spring will be equal to the total frictional force with the ground and total spring energy, the spring's potential energy. This friction force and the spring potential energy will resist the block from coming inside or coming further. So it will, when these two forces, that is the potential energy and the friction force, addition of these two forces will be equal to the force applied by the block, then the block will be at rest, or the velocity of the block will be 0. So we have to calculate this two energy to find this answer of the problem. So let's solve. So applied mechanical energy, it is the total kinetic energy of the body. So kinetic energy of the body is half mv square is equals work done against the frictious force or the friction force, and the friction is given by mu is equals to 50 Newton. So the work done will be mu dot s, work done against the friction force. So 15 cross x is this distance, that the distance the spring has been compressed by, plus the kinetic energy of the spring, that is always half kx square. Now we can solve it. Half m, and you know the v is given 4, 15x plus half kx square it is half, and m is given 2, and this is 4 square means 16, 15x half kx square. And if we put it here, that is half, k means 1000 x square plus 15x minus 16, putting this side, is equals 0, and it will become 5000 x square plus 15x minus 16 is equals to 0. And solving this, we will get x is equal to 5.5 centimeter. So this will be the answer. This problem could be solved in the middle term by middle term factor, and you have to practice the mathematics for faster calculation. Now coming to the problem number 3. it wants to know the centripetal force. We know the centripetal force is equal to the centrifugal force. Both are equal and opposite in a circular motion. So in question, if there is any one like centripetal or centrifugal, the formula is the same. That is the centrifugal force of centripetal is m omega square r. M is the mass of the body, omega is the angular velocity, and r is the radius of the circle. So here m is given 1 gram, omega is 1 radian per second. Always transform it either in SI or in CGS. It is as it is in gram, it is radian in radian, and r is 1 meter. So it is 100 centimeter in SI into 100. So it will become 100. And it is this is CGS system. So 100 CGS, in CGS the unit of force is dyne. In option, to confuse you, there would be option like, there could be options like 100 dyne, 100 Newton, 100 joule, or 100 whatever, or 10,000 dyne. So if you know the system, the unit system, and if you know this formula, you can easily understand that this is the 100 dyne and this is in CGS system. Number 4. It is a very important and a tricky question. Why? The question asks that if a truck is carrying LPG cylinder or the cooking gas, then what will be the change in the temperature of the gas molecule? So you may think that if a truck, like this is a truck, and it is carrying LPG, here is a man driving, so carrying LPG. So if we in normal convention, if there is a container and full of liquid or gas, if we shake it, the molecules changed its velocity or whatever, we can see the change in the molecule. But always remember that if we shake the container of wall of the container, there will be no change in the Brownian motion. There will be no change in the Brownian motion, or there will be no change in molecular motion. No change in molecular motion. So if there is no change in molecular motion, no temperature change. So this is a very tricky question. That is, if we carry LPG gas or cooking gas in a truck, what will be the change in temperature? So no change in temperature. In question number 5, it also know the object distance. So here it is given that magnification is 1 by nth times. So if magnification is 1 by n, then for the convex lens it is equal to the ratio of the object distance to the image distance, or image to the object distance. So we can calculate V is equal to minus U by n. And what is the lensmaker formula? Lensmaker formula 1 by V plus 1 by U is equal to 1 by F. We have to calculate the object distance, that is U. So 1 by U is equals to 1 by F minus 1 by V. 1 by V plus 1 upon V is n by U, right? And this has U, this has U, this will come in this side, U 1 minus n is equals 1 by F. So U is equal to 1 minus n by 1 minus n into n, 1 minus n into F. This is our object distance. Very simple formula, but you have to remember this formula, the magnification formula. Then you can easily solve this, and you have to remember this. You have already remembered this formula. And question number 6, it has the 4 charges are on a circle such that the 4 charge will make a square. So what will be the potential at the center of the square? So this is confusing because there is a 2 geometrical shape, that is circle and one is square. So you can think that you have to calculate the mutual interaction between these 2 charges, but no, they have just asked the potential in the center, and if there is a square within the circle, the vertices of the square will cross at the center of the circle. So simply we know that the potential due to a single charge, all are Q charge, due to a single charge is Q by D. D is the distance between the charges, charge and test charge. And it is also written here, the diameter is 2D. Diameter is 2D. So one diameter is also a vertices of the circle, sorry, of the square. The diagonal of the square. So radius is equal to D, and if we have to calculate the potential, we have to put a test charge on the test point here, suppose V O here. So from this to this the distance is D, this is also D, this is also D, and this is also D. So for a single charge the potential is Q by D, and for all V total is 4 charges into Q by D. So simple, isn't it? But they will make you confused. The question number 7. There is a surface and the flask entering this surface is phi 1, and the flask leaving the surface This is our surface, this is phi 2. So if there is some flask, there must be charge, and the relation between the flask and charge is flask is equal to Q by epsilon 0 with a negative sign. Epsilon 0 is the permittivity of free space. So in this problem we have to find the charge. So there is some charge due to phi 1 and there is also some charge due to phi 2. So the total charge enclosed by the surface will be the difference of the charge due to phi 1 and phi 2. So let the charge enclosed the flask phi 1 is entering the surface due to charge Q1, and the flask leaving phi 2 flask is leaving the surface due to charge Q2. So from this formula we can write Q1 is equal to phi 1 epsilon 0 and Q2 is equal to phi 2 epsilon 0, and both the medium is the same. So the resultant charge Q1 minus Q2, or as we are calculating the resultant, so we will do Q2 minus Q1 and it will be minus phi 2 epsilon 0 minus of minus phi 1 epsilon 0. This will minus phi 2 epsilon 0 plus phi 1 epsilon 0, and it will epsilon 0 in common, phi 1 minus phi 2. So charge due to the resultant charge is equal to Q2 minus Q1 is equal to so keep in mind that if there is Q1 minus Q2, then epsilon if Q2 minus Q1, then it will be epsilon 1 minus epsilon 2, and if it is Q1 minus Q2, it will be epsilon 0 Q2 minus Q1. So keep in mind that you have to calculate the resultant charge, that is the leaving flask minus the enclosed entering flask. So you have to do Q2 minus Q1, and the answer is this. Now come to question number 8. It is given the potential E equals to E0 sin omega t, and the current due to this potential is I0 sin omega t minus pi by 2. So simply we can see that the phase difference between the potential and the current is pi by 2. So theta is equal to pi by 2. So from the formula of power, we have to calculate power. P equals to E0 by root 2 into I0 by root 2 cos theta. So theta is equal to pi by 2 and cos pi by 2 is equals to 0. So P will become 0. So there is a phase difference between the potential and I, phase difference of pi by 2 or 90-degree phase difference between the potential and the current. So the power must be 0. So this is some conceptual question. This is a you can easily use this concept in any tricky questions or any other question, then apply this trick and easily can answer the same. Okay, answer the other questions easily. In question number 9, it is shown that Cu66 turns to Zn in 15 minutes. 7/8 of Cu turns to Zn in 15 minutes. So after 15 minutes, remaining part is 1 minus 7/8, that is 1/8. And then for the remaining part there is a formula is 1/2L and it is equal to 8 remaining. And the n is time, it is half-life time. So 1/2 to the power n is equals to 2 cube 8. So n is equal to 3. We get it. So in 15 minutes 7/8 part is decaying. So the half-life will be 15 divided by 3, the time, and it is equal to 5 minutes. Okay, very easy question. And now question number 10. Here I passed 2 questions in one question. Those are likely questions. Often you can get this in question paper about digital circuit. And another is you have to find out the output Y and identify the gate. So this is a AND gate, this is a NOT gate. So AND over NOT, it becomes NAND. And this is a OR gate and this is a NOT gate. So AND NOT over OR, it is a NOR. NOT over AND is NAND and NOT over OR is NOR. Quite simple. Now if there is a little change in the circuit, what will it become? Generally NAND gate is look like this. This is AND and the round shape of NOT is here, and NOR is looking like this. Okay. So if we do a little change putting over this, so this becomes a NAND gate. This becomes a NAND gate. A after this, and this is a NOT gate. So it will again become NAND bar. NOT is some bar, NAND bar, and it will be again AND. And in this case, for this will become a NOR gate, and this is a NOT gate. So NOR over bar, and it will become a OR. These are the tricky questions, but very easy questions. And now this is a bonus question for you. One important question. In the question it is given that the power in the 9 ohm resistance is 36 watt. So what is the potential in 2 ohm resistance? So if there is power, we can easily calculate the current in it, because we don't know the voltage. So P is equals to I square R. So 36 is equal to I square R is 9, and I square is equal to 4. So I is equal to 2 ampere. So simple. And from the resistance, from this resistance, we can easily calculate the current in 9 ohm by the formula using total current entering the circuit into the actual current, that is 6 by 9 plus 6, and it is, we know this is 2 I into 6 by 15. So I is 15 into 2 by 6, 5 ampere. This is our current in the circuit. We get it from here. So now we have to calculate the potential in 2 ohm. So potential in 2 ohm, potential is the voltage, V is equal to IR, and I in the circuit is 5, R 2 ohm, that is 10 volt. So the potential is 10 volt. Very simple question, just step calculations.